Hey guys, this video is gonna give you a brief how-to on how to deal with our configure it question assignments for our homework sets. You'll have a configure it question, one per assignment for homework sets 1 through 5. So the first time you'll see this is up on homework set 1, and these are these guys right here that have the double asterisks that say, hey, this is a proof to work on from the configure it website. The first time you go to configure it, you need to set up an account. Our class code is given right here at the bottom, and the link to set all that stuff up to build your account is given right here. But what I'm going to show you in this brief video is how to actually use that configure it site. So when I go to this, well, when I set things up, I'll go to teacher sign in. You guys could go to student sign in, but to just go in and work it, just go ahead and click the button. And I was lazy and saved my password. So you'll log in, and then you go to whatever it is that you're trying to work on. Now, you may see something a little bit different, but what will happen is I've actually assigned activities for us, and this is not all the activities, this is just some of them, far more than what you'll actually be assigned for credit in this class, but ones that both tie in to other things that we're doing, as well as just ones that were interesting, but far less than are actually in the site itself. So I went ahead and clicked on one of these guys. This is not one that you have for a homework assignment. This is just an illustration of how to use the configure it site. Okay, so in terms of what this question wants you to do, it wants you to, or the goal is to prove that these two triangles are congruent. Notice when I hover over it, it actually highlights which two triangles in the picture are congruent. You can do that over here as well. Okay, so we want these two smaller triangles to actually be congruent to each other. Now, notice here in terms of pieces and parts, unjustified claims means these are the things you still want to prove. Justified claims, these are the ones that you are either given. Right now you're given, or your starting point is two things. One, the triangle ABC is isosceles. Notice it highlighted there, triangle ABC in purple. And that D is a midpoint of the side AC. Now in the picture, it also gives you one extra thing that you have this line B to D. Okay? These are the things that we already know are true. The justified means we already know they're true. Now, somehow, we have to get from this information that we're given over to this information, and that's the nature of every single type of proof. Now, what configure it will do is it will only allow you to put in a next step if it fundamentally and logically follows from your justified claims. In other words, your previous steps if you were writing this by hand. So there's a bunch of different ways that you can do this. You can click on the button Add Claim, and it will give you a menu. You'll go through and you can look at things that relate to points, lines, angles, triangles, other shapes, circles. Maybe you pick on a triangle because we have triangles here. And notice it starts talking about things of, are we looking at congruent triangles? Are we looking at similar triangles, right triangles, isosceles triangles, other different types of things. So here we're trying to get to congruent triangles. Maybe you click on congruent triangles. It says, all right, well, which triangles do you care about? And notice here, you can actually point and click. And oops, I clicked on the wrong one. So you can also go in and type which triangle you care about. For this triangle, you can also go in and click on it, and notice, be a little bit more careful this time. Point and click. But we could have also, and I'm going to delete what I just did, have gotten these two triangles by coming, oh, nope, it didn't work that time. Getting those two triangles by, and let me go ahead and pull them back up here. All right. So notice this is the claim. It says confirm that that's yes, you actually typed it in correctly like you wanted. And then what it's going to tell you is, all right, well, that's just a claim. You have to justify it. You have to explain why. And at this point, it's a lot of different things. And you're like, you know what? I don't know yet. So justify it later. Notice it pops right up here with these other ones. And since that's the same as the previous one, I'm going to go ahead and delete that. Now, let's do this the way that I think is easier and a way to make it so you're bogged down less. If you go to justified claims and click on one of them, notice what it brings down in a menu. Instead of going to the entire menu of all the things you could do, this only ties you down to a menu of what's associated with an isosceles triangle in this case. So what's something with an isosceles triangle? Well, you can have two options. If you have an isosceles triangle, by definition, you know two of the sides are congruent, and by theorem or proposition, you know that its two angles are congruent. This configure it website is not designed to be as precise as what we're going to need in our class. So it does not tell you the names of certain things like what we have. Instead, it gives you descriptions. It also doesn't differentiate between definitions and propositions, which is something that we're going to need to do in the future. Okay, so that is one of the downfalls of this, but the really, really big important thing is it only allows you to do things that are legitimately valid things to do. So here then we've got Isosceles Triangle. We selected the one where two sides are congruent, so now I want to select these two sides. I could totally type them in. So I want to say that these two sides are congruent. So I could type in AB. I did not hold down the shift key to do capital letters. It automatically are capital letters there for you. Notice it also has the bar up top to indicate a straight line automatically for you as well. Now let's do it the other way. You can also just highlight your line segment, and that's the easiest way to point and click. Okay. Notice at this point, what did we get? We now got that those two line segments were congruent to each other, and it filled in that information on the picture as well as putting it under justified claims. Now, we had an isosceles triangle, and there were two things you could have gotten from an isosceles triangle, so let's go back and look at the other one. We already used that one, so if we use the other one, which deals with angles, and I'm going to be lazy and do the point and click version of the angles here. Fill it in. Bam, we get that piece of information too. Now, maybe you don't want both of those pieces of information. In this case, I'm going to claim actually we'll be able to use both of those two pieces of information in the future. But notice, regardless of whether you use the piece of information in the future or not, at that point, both of those pieces of information were legitimate and you could totally use them at that point in time. Okay. Now, that's all we got with respect to isosceles triangles. Remember what we're trying to get to. We're trying to get to congruent triangles. Congruent triangles means all three angles and all three sides associated across the two triangles are congruent to each other. Right now we have one pair of sides and one pair of angles are congruent. So there's 4 extra unknown pieces. Okay. So what if we haven't used? We didn't use the given here that D is a midpoint of AC. So if we click on that one, we see there's a bunch of different things you could do with it. Well, what do we need? We need to know if there's any extra pairs of angles that are congruent or any extra pairs of sides that are congruent. Notice there's no angles really associated with this too much. Maybe a little bit here with the right angle, but we're not told that we have a perpendicular bisector. We're only told that we know midpoint. So this one actually wouldn't necessarily be applicable. So go to the one that for sure works. We got that D is a midpoint of AC. What does that tell us? That means each of these two pieces better be the same. So if we click on AD here, make sure I actually select AD, and then DC, make sure I actually select DC, and that tells us that, yep, we should have now those bottom two line segments are congruent to each other. And notice here, just like with the last two pieces of information, we now have the symbols color-coded in our picture to show congruence as well. Now at this point, could you keep on going with trying to find pairs of angles and sides that are congruent? The answer is yes, you actually could find another pair of sides that are congruent. BD is congruent to itself, so that's true across both triangles. And it'd be a little tricky to deal with the angle down here and with the angle up there with the information we have. So instead of doing any of that extra work, instead I'm going to jump directly to using one of the triangle congruence theorems, which notice we have a side, we have an angle, we have another side, and the matching corresponding sides and angles over on the other triangle. This tells us that what are we going to want to do? We're going to want to justify that those two triangles are congruent to each other by way of side, angle, side. Now notice here when I clicked on the thing I want to get to and it shows a bunch of pictures, once we hover it'll actually tell you the name. So the first one there actually turned out to be side, angle, side, 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 angle, side, angle, 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 side, and the last one actually is not the real name. This guy is normally called right angle, side, side. This particular website calls it something else. So I went ahead and clicked on side, angle, side, and notice in order to use side, angle, side, you have to have already established 3 facts. You have to have the side, the angle, and the side. These are corresponding pairs across the two triangles. So notice here we've actually already done that in the picture. We can see that happening. So I'm going to just go over to the stuff we've already done and said, hey, yep, we've got that pair of sides. Click on the pair of angles so I don't have to retype it. Click on the pair of sides again. Please note that everything on this side has to correspond to that triangle, everything on that side has to correspond to the other triangle. You do have to watch out for that, because if you accidentally put things on the wrong sides of the congruent symbol in this website, it will actually say, I'm sorry, that doesn't work, just of how the computer is checking it. And notice, as soon as you get that target goal, that claim justified, which was the one you wanted to get to, it doesn't allow you to keep going. It says, bam, you're done. Okay. Now, at this point, you've finished using your configure it site to prove whatever it is that you were asked to prove. And maybe you say, hey, I want to go ahead and try something else because this wasn't an assigned proof. Or maybe you say, this was a homework question, I want to go ahead, print it out. I want to print it to a PDF file, which you can totally do. For example, just change this up, save as a PDF. But then you say, you know what? That actually doesn't look good. Please, please don't actually print it with a well done on top of it. Okay? So in this particular case, it's covering it up. So there's actually a better way to print this out. So I'm going to cancel this. You could also notice, click on the Y button right here, and it will pull up the 2-column or T-chart form. It doesn't use statements and reasons like we do, but it's got the same thing. Over here, it's got all of the statements we care about. Over here, it's got all of your definitions and propositions, except these really, really long descriptions are in fact not what we're going to use for our class. Instead, we would say something like definition of a midpoint, definition of an isosceles triangle, and this would be one of our propositions with a number. But the best place in terms of printing is actually not there either. It's where you go all the way up to the very top right here, click on print, and notice here it'll print the picture and it will print all of your work. And if you did happen to have extra steps in there, no worries. As long as you get to verifying this target at the bottom, even if you had extra steps, the logic that you used was correct. Okay? And at this point, you can then hit save. You got a PDF, and don't forget to upload that with whichever homework it was associated with. And that's it in terms of the crash course.